Look at that. 8.85 millimeters. You see that? Are you getting this? I mean, is this soaking up? I mean, soaking in. Okay. Now, what I'm going to do is I'm probably going to make a bunch of different slides of this whenever we get ready to do another test, and we're going to have them timed. You got 30 seconds to do each one. Bam, bam. Ooh, that would be bad, wouldn't it? But you can get good at it. Okay, see what you can tell me about this one. Brenda, take this one and tell me where we are. Come on.
Would it be before?
All right, what's back this way?
3?
No.
No.
Well, this is 1 point.
1 point.
1.5 what? If it was that line, it would be 1.575, wouldn't it? Okay, so we got to know what to add to 75 to come to our right answer. Now look like it lines up?
Yep.
So what's that going to be?
90.
What's the whole reading?
1.19.
1 point what?
1.59.
1.590. Understand that? You got it? George, you getting this? George, come on. Yeah, see, you're actually adding whatever this number is to whatever that one is. That's 525, 550, 575, plus 15. See? 1.5, it's 25, 50. It's more than 75. How much more than 75 is it? If you look at this one that lines up perfectly, add that to 1.575. You got to be able to do this now. This is going to be your final. You have a timed exam. Okay, now look at the millimeters up here. Okay, so this is, how many millimeters would this be? Sean? How many millimeters?
4.
I mean, this is 40 millimeters, obviously, because you got 10 millimeters between. Okay, 40 millimeters. It's just over 41. How much over 41?
Goes to the 5.
Well, yeah. Wouldn't you guys say 4 lines up a little better? At least on that picture?
4.5.
Huh? Okay. Okay, so that's not quite, and you can also do it by thinking about this. This is not quite halfway between those two lines. This one's lined up, well, this one actually is lined up better than that one is. All right, so 45 hundredths of a millimeter. This is 41.45. You able to read those? 41.45. The metric one is easier to read, really, the millimeters, than the other ones. You get right down to it. Here's another one. Daniel, what do you think?
1.4, and then we got 25.
There's the 25 line.
Lined up at 15.
16?
16.
What's 25 and 16?
41.
See how important it is to be able to do math in your head? Okay. Now then, what's the meters? Derek? What's the metrics? Did you get that? How many millimeters you starting out with? 1, 2, 3, 4, 5, 6. I'm past 36. So here's 5. There's 6. All right, now what lines up?
5.
Huh? No, you're looking up here.
6. Yeah, 6 or 7.
Well, 7 is not quite. That'd be 7 there. Look, when you said that was lined up better.
Yeah.
Okay, so what are you gonna write down?
36. 40.
That one right there. What is that? What does that represent here?
65.
65. 36.65. Got it? Okay. We're getting there. George, you ready to do one?
Again.
You scared of it? Come on. Okay, get George in inches. This one's less than an inch, isn't it? Okay, so if it's less than an inch, you're going to start out with 0 point. That's going to be the first part of your reading. 0 point. Okay, where's your 0? Okay, it's 0.7. Right? All right, so what's this? If it was right here, what would it be? That would be 7.25, 750, 775. And look down here and see which one of these lines up. Your base is 775. You got to know how much more than 775 it is. What does that say?
10.
So what's 775 plus 10? 0.785. Got it? All right. Okay, George, take another crack. What you got here? How many? Oh my goodness, look at here. This one's plumb easy. Looks to me like that's lined up right on the money. So what is that? How many millimeters is that? Well, no, it's actually, look, this is, you should, look, it starts back here, 10, 20, 30, 40, 50. These should have zeros next to them, but they don't. They're decameters, basically. A decameter is 10 millimeters. Right? So that's going to be 20 millimeters, isn't it? Or just right on it. Understand? It's time for the web to get involved now. Mr. Webb. Read the inches for me, Mr. Webb. Two is good. 2 point what? What's the next? What's right next to your decimal on the right side? 2 point what? Okay. What's past 4? You got to tell me what's past 4. 2.4 what? It's more than 50, but not quite 75, right? So 2.450. What lines up down here? That one really does, doesn't it? So that's actually what? 20 plus 1. Okay. 50 plus 21 equals what?
71.
All right. So there you go. What is it? Now what's your actual reading? 2 point what? 2.4. Yeah, 2.471. It usually takes a few of these before some people catch on quicker than others. All right, you see one here? What do you see here? Do you notice when the 0 lines up perfectly, the 25 does too? That's because they're the same. It's the same reading. In other words, that 0 right there is lining up, so it's right on the 25. That's a perfect example of that. But what about this one up here? See that? Well, what is this down here, by the way? This is less than 2, but more than 1. So it's 1.6. What? 1.650. 1.650. You got 3 places past your decimal. All right. And up here, what do we got? How many millimeters is that? This is 50 millimeters, and we're lined up with that one right there. We're 3 back from 45. So what's that?
42.
So that's slightly less than 42. Slightly less. It's 41 and almost 42. Which one lines up perfectly? Heck, it looks to me like the 10 does, but if you got some parallax, if you can turn your gauge and look at it, you're going to see that those are pretty well lined up. So if this one right here is 1.650, it looks like, for all intents and purposes, that's almost exactly the same as 42 millimeters, isn't it? Because see how the zeros are all lining up everywhere? Every now and then you run across that. And that was the end of the slideshow. Now, if I gave you guys a timed exam on that, how well would you do on it? 30 seconds to answer each one. I tell you what, when I was in hybrid school, he put some schematics up here, and he says, how many amps is this circuit pulling at each place? You got 30 seconds. And the guys had to write this stuff down. And then he'd say, he put a more complicated one up there. He said, how many volts and how many amps is it pulling at each one of these places? And he says, you got 60 seconds. And there were 16 people in that class. 3 of us got all those right. There was me and 2 other guys that got all right. I don't know if I just got lucky or whatever, but anyway. All right, now I'm going to stop that and Fundamentals Test 3. Hazardous materials include all of the following except what? Hazardous materials.
Water.
Water, yeah. That's dihydrogen monoxide. All right, to determine if a product or a substance is being used is hazardous, consult what? Materials safety data sheet, yeah.
Is that thing out there?
Yeah, that's supposed to tell you if any chemical that we're using is supposed to have one of those in that box out there. And see, the manufacturer of the chemical is supposed to be able to produce that for you on demand. And the Ford Motor Company used to have all of theirs listed on their shop manual material. Every Ford chemical that we had in the parts room, and it would tell you what would happen if you swallowed it, what if you got it in your eyes, how it's supposed to be treated, and that particular copy of that would be sent to the hospital with somebody if they accidentally ingested a half a gallon of carburetor cleaner or something. See what I'm saying? They'd probably be dead meat anyway. But exposure to asbestos dust can cause what condition? Mesothelioma.
Oh, that was B.
Well, it basically is B, but that's a screwed up, scrambled answer. So B is actually going to be the one that, all of the above. Just consider mesothelioma as being one of the above. That question's messed up. Wetted asbestos dust is considered to be what? In other words, huh?
That ought to be all above right there.
Solid waste. It's just solid waste is all it is. If it's wet, you're not going to breathe it if it's wet, unless you're a fish. Okay. An oil filter should be hot drained for how long before disposing of the filter? Now, the state people that come over here and sniff around, make sure we're doing like we're supposed to, they said 24 hours. But this thing says 12. And when you say hot drained, you poke a hole in it and let it drain. And we used to stab a hole in it, we put it in that little red can, we let it drain, and we put it in the trash. Now, we actually use a drum that Safety Clean brings over here that we just throw the oil filter in there. And then when the drum gets full, they haul the drum away. Our waste oil container is getting full. I don't know if you noticed that or not. I mean, it's above the black part of it now, above the containment part. A used engine oil should be disposed of by all of these methods except what? Except you don't want to pour used engine oil in a regular trash. It's just bad news to do that. We only got 18 questions here. The thread pitch of a bolt is measured in what units?
Threads per inch in millimeters.
Yeah, both A and B. The thread per inch would be how many times you got to turn that bolt before it'll go an inch, or you can actually measure them, with a little gauge. Or if you measure on a metric bolt, you're going to measure it from peak to peak. We talked about that before. The metric bolt is measured, like if you look at the side of the bolt, from here to here is the measurement.
It's like measuring a frequency or something, wave crest to wave crest.
Sort of, yeah, that's a nice way to think about it. But on your standard bolts, you're going to measure how many of these are in an inch. And on the metric bolts, you're going to measure how far apart these are in millimeters. And see how they do them different. Do you know how metric wire is measured?
Gauge.
It is, but it's different. It's measured in millimeters. Like if you see a 0.5 wire in your wiring schematic, 0.5, that means it's a half a millimeter. If you see a 1.0 wire, it's a 1 millimeter. If you see an 8.0 wire, it's an 8 millimeter wire. See, so the higher you go with your gauge on metric, the heavier the wire size is. The higher you go with your gauge on an English wire, the smaller the wire is. So they're just diametrically opposite from one another the way they go. A 22 gauge wire is smaller than a 20 gauge wire. Think about your shotguns. A 20 gauge shotgun's got a smaller shell. than a 12 gauge. And a 10 gauge is smaller than both of those, right? And an 8 gauge is a monster, right? All right, so think about that. You also got, you know, what if you get down below to the biggest wire you can think of as far as battery cable wire is what? As far as gauge. They've got 2 gauge. It goes down, you know, it goes 12, 10, you know, 6, 4, 2, and then where does it go?
Alt.
And then what?
Alt.
Double alt. Triple alt. I mean, if it goes to 0, you know, it goes actually below, and then you got 2, you know, double alt wires, big heavy duty wires, big as your thumb, you know. All right, so that's, yeah. Okay, technician A says the diameter of the bolt's the same as the wrench size used to remove or install the fastener. Technician B says the length is measured from the top of the head to the end of the bolt. Neither one of those guys are right. You guys know that. The grade of a fastener, such as a bolt, is the measure of its what? The grade of it would be how, you know, strong it is. So what is that?
Tensile strength.
Tensile strength means what, Sean?
How much pressure it can hold, basically.
How much pull, what it takes to pull it apart. Now, I will tell you this. I went out there one time, heck, I guess I was 20 or 21, and there was a truck we had sold to this helicopter corporation out there at the airport that was a 71 Chevy ton-and-a-half truck. First, I had to put a 1,500 gallon gas tank on it and pipe all that stuff with the meters and all that kind of stuff. When I say pipe it, I mean cut threads on the pipes and put pipe dope, put them together where they wouldn't leak and all that hot wire. So I had to do that. I had to put a PTO on the side of the transmission, and I had to put a drive shaft, and I had to mount a pump under there, and I had to use that pump so that when you brought the engine RPM up and engage that PTO, you'd be pumping helicopter fuel, right? So I had to do all that stuff first, you know. I mean, they give you tough jobs down there in the oil patch, you know what I'm saying? And you don't usually give a 20-year-old guy that kind of a job to do, but I had it to do. But anyway, I got that done. And they were driving through the Gulf Oil Refinery one day, and the bearing on the outside of the, you know, the outer wheel bearing out here on the front, and they had drum brakes on the front of the 71 Chevrolet truck. That bearing seized up, twisted the end of that spindle off, and the wheel of the brake drum came off, and it wiped all the brake parts, all slam up to the backing plate, and ruined the backing plate. So now the thing needs a spindle, a backing plate, and all the brake parts. So what happened there? It's out at the airport. They got it hauled from. It happened in the Gulf Oil Refinery when they were going through there. So they said, throw a toolbox on the back of your truck, go out there to the airport and fix that. Well, think about it. You know, what you got to do? Take your purchase order book. So I went out there and I made an assessment of what I needed. I needed a backing plate, I needed a spindle, I needed all the brake parts, and I needed a set of brake shoes. All the brake parts mean springs, you know, and all that. Well, what do you got to do to replace a spindle? You got to take a little bolt out, and you got to, I mean, this goes into a dimple in the kingpin. You got to get the kingpin out of there. Well, this is where I'm going with that. I says, how am I going? So I got the little pin you had to drive out of there. It's actually a little wedge-shaped pin you drove over there. It was holding the kingpin. The kingpin is actually the part that the spindle, you know, moves on, and it's got bushings in it and all. But I had to have a new spindle too. So anyway, I took that thing and I said, I'm going to take a balancer puller I've got, and I'm going to put 2 bolts in it, because there was a little cap that had bolt holes on either side of that spindle. Kind of looked like this right here. The top of the spindle looked like that. There's a bolt hole here and a bolt hole here. And I put my balancer puller up here, and I put balancers through that, and my big screw part of my balancer was pushing on that kingpin. I was going to push it out of there. See, because this part right here that you're seeing is the axle, and the kingpin had to come out of it. And so I got 2 bolts out of my junk drawer in my toolbox that were 1/4-inch bolts. One of them was a Lake Erie brand American-made bolt. The other one was some Chinese-made, both of them grade 5. One of them had a triangle on top of it, which you don't know who made that one. And the other one had LE, they meant Lake Erie. And when I started applying pressure to that Chinese-made bolt stretched. That tensile strength, okay? I mean, I literally stretched the Chinese-made bolt, and I had to go find another Lake Erie bolt in my dadgum toolbox, because that Chinese bolt, if both grade 5, that Chinese-made bolt wouldn't handle the stress that Lake Erie bolt would. Totally different. But anyway, but I got that truck fixed, and it was blowing rain, and it was cold, And I was out there at the airport, and you know, at the airport, there's nothing to stop the wind because you're wide open spaces. Anyway, that was a wild adventure. My goodness, that was probably in 1978 or something. But anyway, the grade of a fastener, such as a bolt, is considered a tensile strength. Which of the following is a metric bolt?
D.
D, M12 by 1.5. What does that mean? What's M12 mean?
That's the diameter and the thread pitch. I think about the diameter.
The diameter of the bolt. This one here is actually an M10 by 1.5, right? Okay, this one here, the diameter of it, and then 1.5 is going to be your thread pitch. Now, what's the wrench size on this 10 millimeter bolt?
That's 13 or 14.
What do you think?
17.
It's actually going to be a 17, right? Be 11/16, real close to that. All right. A bolt that's threaded into a casting is often called a what? You're going to call this. You're going to call it a cap screw, right? Okay. What's a stud? Somebody tell me what a stud is.
Stud is like one of those transmission bolts that's got a it's like a permanently mounted fastener in the middle, and usually it'll be set like that so you can put a ground or something on the other side, and you'll put another fastener on the other side of that.
It's basically thread sticking up that doesn't have a head on it that a nut goes on. Okay, tell me thread pitch and wrench size on that one. Okay. So anyway, that's actually going to be both B and C. I'm sorry, excuse me. That's a. I jumped over number 12, didn't I? Or did I? Cap screw. Yeah, I know I didn't. 12 was the next one. The marks on the lines on the head of the bolt indicate what? That's B and C, right? It's going to be grade and tensile strength, which is the same deal. When working with hand tools, when possible, you're supposed to pull the wrench and not push it. But everybody that's ever pulled wrenches is going to tell you that there are times when you absolutely cannot pull the dadgum wrench. You're going to have to push it. You know, the guys that sell the wrenches will tell you, don't ever push on a wrench, always pull. Well, they ain't worked on nothing. I'm sorry, but there's just times you got to push on it. That's all there is to it. And I was pushing on one time, hyperextended my knee. And it was bad. I talked about that before. The proper term for channel locks is that a silly question or what? Multi-groove adjustable pliers. I called that girl at the parts house one day because Brett wasn't there, and I says, I need to send me a set of channel locks, and she sent me some vice grips. All right. Okay, the proper term for vice grips is locking pliers. Okay, what company makes vice grips? Who was the first people that made vice grips, you remember? Vice grips. Who made them?
Sears and Roebuck?
Nope. Irwin. That's the name of that company. Irwin makes vice grips. Which tool is listed as a brand name? Vice grips. They got vice grips on the side of it. Two technicians are discussing torque wrenches. Technician A says a torque wrench is capable of tightening a fastener with more torque than a conventional breaker bar or ratchet.
That's hogwash.
That's nonsense. Technician B says a torque wrench should be calibrated regularly for the most accurate results. That's Technician B. And finally, last but not least, number 18, what type of screwdriver should be used if there is very limited space above the head of the fastener?
Offset.
Offset screwdriver, but I like to stick an air ratchet in there with a screwdriver bit if I can, you know. And incidentally, over there on the wall, look at that. I want you to look real close at those. Right over there, I want you to know, take special note of those different types of screws. You see that? Now watch this. Somebody tell me what kind of screw this is.
It's a positive,
How do you know?
because it's got the squared off tip to it.
And you notice that it's also got little mountainous teeth that are in between the big ones. And see how this runs straight instead of being tapered? Now, most people will grab a Phillips to screw one of these out, and that's okay, unless it's really, really tight. Posit-drive screws are typically harder screws than Phillips screws.
a bunch of those on my chainsaw, I noticed.
Yep. What's the most annoying thing about Phillips screws is they're really, really tight. Sometimes they'll round out. Particularly if you're using, and how many of you have dipped your screwdriver in valve grinding compound to go in there and get them the rest of the way out? I mean, because that valve grinding compound is a gritty stuff and it provides a lot of purchase points. Usually it will help you get them out, unless some of the students sometimes will bring something to a total disaster where it's completely rounded off, and then we'll be working a miracle to get it out of there, you know. Of course, that's a, what do you call this?
There's a, Torx.
No,
The
Torx
Torx
is over here.
It's just Allen shape.
Yeah, Allen is good, but they also call it a socket head screw. Right, and that one there, everybody's seen one of those. But this one right here, I'm gonna tell you something really important about this. If you've got a Torx that's the right size to go in here, it will turn an Allen better than an Allen will. I mean, it literally will. It's less likely to round that Allen head out than an Allen wrench is. So this right here, if you've got one the right size, is better to use on an Allen than an Allen.
Back when I was a heathen and didn't know no better, I got frustrated with one of those, couldn't find the right size, the right one to do it with. I just take a hacksaw and turn it to a flathead.
If that will work unless it's really, really tight. And those are typically harder than a regular screw too. All socket head cap screws are grade 8. Every one of them. So that's what I was told by a parts guy one time. So that got you